Hello everyone, welcome to the stream. Today we are looking at creating Flying Fox. Last time we added Verlet Integration. Since then there was Christmas and New Year's. Nothing really else. So let's start off. First, we can add a jumping mechanic. This will be in the player system since it is specific for the player. So we can just going to quickly add it, because how you add anything in code is you first duct tape it to the wall and then you do it properly. So let me just add my duct tape. Get input if keyboard get state, the state of the keyboard keys is key down. Let's say we want the space key, since we want it to be the jump key. Then we say RB, this is the player rigid body. As you can see, our player, get the rigid body for the player. We'll apply a force. In Monogame, everything is tilted upside down. Just show you, everything is tilted upside down, unlike the usual Cartesian plane you find in maths. It is that's one. You'll see it's, why is this not drawing what I want? There we go. This is negative and this is positive, as well as this is negative and this is positive. So this is Monogame. Oh, Monogame. Oh, just get my lines a bit better. I just get my ruler. And say, there we go. In maths, it's the other way around. So this is also negative, this is also positive. So this has various implications, like sine and cosine being switched around. So you will learn in maths that this, and all of the trigonometric expressions is positive in this quadrant, and only sine in this one, and tangent in this one, and cosine in this one. If you look at Monogame, we'll see it's swapped around. So let's say this will be all, as you can see, plus, plus, plus. This is negative, positive. So this will be cosine. Maybe I'm making a mistake here. Just going with it. There we go. So it's different. So when you have to do transformations, such as getting the rotation for the player, you will use different trigonometric expressions than you would use in maths. So just something to keep in mind. For now, you don't have to worry about it too much. So we want to move it upwards in the y direction. So let's just say here 0.1f. Let's see. Run it. Visual Studio is catching up to us. We're fastening it. Imagine that being fastened in a computer. There you go, it falls. Now, something's not working. Maybe because gravity is stronger than our actual jumping force, or equal to, so this is 1 and 1. So nothing will happen. Just test it again, change it to 9 or something huge. And we'll try it again. If you have any questions, you're welcome to ask in chat. There we go. Or in the comments if you're watching this recording. See, it's a bit floaty. That's not a problem now. Not yet, anyway. So we want, the problem is, let me just put this on the screen again. When you press space and you hold it in, player flies up like Flappy Bird. In my Flappy Bird clone anyway, it's not supposed to. It's supposed to go like that. But if you hold down space, it will do that. Monogame doesn't support looking if a key was pressed. So you can just implement it yourself. So let's create a new class. Just for this, since we don't really need, we just want to keep it nice and tidy. Let's just call this class input.cs. And we will make, you need an alt state, keyboard state, alt state. So this will keep track of the previous state. So if it wasn't pressed and we press it, this would check if it was pressed. Alt state, and we want keyboard state, new state. Now we want this to be updated each frame. So public void with update. For now, I'm not going to put anything in there. We just want to update each frame. So we will say just check here on what I did previously. Keyboard state. Not sure. Okay. Old state equals new state. And new state should be keyboard.getState. There we go. Now we'll make this public. No, we will not make this public. That's a bad idea. Bad design. We will get the specific state of a specific key. So that will be, just check what class is called. Usually I can't remember. Keys. Okay, we're fine. Public boolean get state of a keyboard key. So that's keys key. Key you want to get the keyboard, the input for. So that will return alt. Let's say new state dot get pressed. And you would say dot is key down. Is key down key. Okay, this is basically exactly what we're using of Monogame. To get if it was pressed, we'll just need to do some other methods. Let's say was key pressed is key. Actually, this should not be updated. Since when it's going to be updated, it's going to be updated before we call WasKeyPressed. So that's not a good design. We want to say alt state boolean temporary will be alt state is key down key. Let's say this, just call this alt and say boolean new is new state is key down key. Okay. New new key state and old key state. And now we can just go, let's say return, just say if old key state is false and new key state is true, then true, else then false. There's the duct tape. And we will say old key state is equal to new. Let's just say old state equals new state. And we will start this off by saying new state is equal to keyboard dot get state. Now we don't even have to update it. We can just remove this. And this will be a static method. What's the problem? Static field. Okay, we'll make this static. Maybe this won't work. We will see. Static. Okay. So we'll just say where's play system. If input dot WasKeyPressed keys dot space. Hopefully this works. Let's see. Let's see if the duct tape is holding the painting. Ah, it works. See, I'm holding it in. It just goes up a little bit and down. Now, let's just make this more visible. I'm not sure if YouTube's compression will prevent you from seeing anything. Probably. It just might do that. See here. There we go. Now you can just repeatedly, can't hold it in anymore, but you can just press it repeatedly. And now you have Flappy Bird mechanics. There we go. Let's just take that out again. Great. Now the next problem is we want the player to only be able to jump when he is on ground. If we look at the sketch, let's go. Oh, it's terrible. The light. Let's just take that out of full screen. Let's just draw our ground here. We only want our player to be able to jump if on ground. Otherwise, we don't want it to jump, because currently we jump when space was pressed. Which is a bit of a problem, because we want to make a platformer. And we don't want flying hacks in our platformer. So we will create a new variable, isGround, or onGround, whatever you'd like to call it. We will store it in the player system. It will be a boolean, private boolean. Only this needs access to it. Is on ground. Now, if the rigid body, the player's rigid body, is position dot y is equal to our flying fox dot max the map height, then is on ground should be true. else it should be false. Now we can say if the if space was pressed and the player is on ground, then apply the jumping force. Visual Studio is running. There you go. And now we can no longer hack our way past it. It's a bit floaty still, but that can be fixed by just making gravity bigger. Our next problem we can solve is, as you can see, maybe you can't see, it is only detecting that the player is on the map height when the middle of the player is on map height. And it looks a bit weird. This is because when you use rectangles and you put in a center for it by rendering it, let's see here, let me show you. In sprite, we just go to the sprite class. Okay, it's not in here. I see we can do it like that. It's in here. There we go. When we draw it at the position.transform, this is the origin. Oh no. Monogame just draws everything with the origin in mind. So let's say you see here, this is the middle of the texture. So now, since you've put the origin in there, the position, this will be relative to this. So it will no longer be at the top left. So let me just illustrate this, because your words don't work. So usually, make this line fit, figure. There's your, if you put nothing in origin, in other words, you say origin is 0, 0, the position will be here. Pos position will be there. But when you give a value for origin, let's say the center of the square, like 4, 4. Now, position will be there. That is a bit of a problem. Can become very irritating because if nothing is, collision detection will be off. All your detections will be off for which you use position. So what we can do to fix this is, well, many ways. The one we will use here, with duct tape again, is we will take the size of the rigid body and add it to that position. So this will be, this point we will get by adding the maximum half of the texture to the position, and by adding it also in the x direction, and this will be max. This will be max y and max x. So max y and max x. And this will be min y and min x. And this again, max y and min x. And this will be min y and max x. So then we have all 4 corners of the rigid body. It's a bit of a hassle to implement this, but it's fine. We'll just put it in. Once you've put it in, it's easy to use. But getting it in is not always the best. It's not the funnest way to do it. So let's just put it in. There's no other way of doing it I can think of. I'm only limited by my own imagination, which might be pretty limited. So we want the public vector2. We'll just think, do we want the vector2 or do we want a float? You can just see here. We will just put this in the vector2. Min and max. And we want public, not really a float, it's an int. Int width and height. Okay. So we can just initialize everything. Wait, this will be a irritation. This won't work because if you change position, you will have to change min and max. So you have to return min and max in regards to position. So you will need to create a new coordinate every time. Otherwise, if you set it in, let's say, rigid body, it wouldn't just create undefined behavior, just to simplify it. So we can just say width and height we can initialize in this, because that won't change throughout the game. So let's do width equals width. Width dot height equals height. So we can just ask for width. Okay. And int height. Just fix that spelling. Now we will need to initialize this in the player system. It's complaining. For now, we won't. You actually want this in a variable, like the sprite. But for now, don't worry about it. We're just going to do this manually. 8 and 8. Now we have min. We can calculate min and max from, is it? Sprite, from the width and height. So min will be get return new vector2. It's not ideal because you will create a new vector2 every single time you ask for min or max. But again, duct tape against the wall. So new vector2. Make this position on x plus width divided by 2, since it's from the center, and position of y minus height over 2. Here I've got, it's a minus, since you want the top left. Since you want this spot, you will take this minus that thing and minus that thing. Just get it on a color here. And that will result in that point. There you go. And just copy this. Make this max. This will be plus and plus. Okay. So what you can do is you can say position. Don't even need position, you can just say min x. So when, no, not min, max. Because we want to check if the maximum point is above or below, if you can say. It's my colors here. you want to check if this point, this x coordinate, the max x coordinate, no, not that point, sorry, this coordinate, this is max x, if that is greater than the map width. So this would be the map width. Also, if this point is here, it's wrong. So we need to move back the square. So we check if max.x is greater than map width, we move it back. Otherwise, we do nothing against it. So max.x. Now we want to check if this side, max.min.x, sorry, this one is here. If it is, move it back. So we know we just calculated that, so we can just say min.x is smaller than 0. Because our map is centered, not centered, its corner, top left corner, is 0 and 0. We'll just use it like that, otherwise there's no real reason why you want to do it otherwise. Unless I can't think of it, but just keep it like that and you'll be fine. Now we want to do the same for y. So if the maximum y point is greater than the map height, move it back. The minimum y point is smaller than 0, move it forward. Or up, down, down. Move it down. Let's check if it works. Come on, Monogame. See. It's not working. Question is why? Why is it not working? Min x. See. Okay, it's here. Here's the fault somewhere. Position is equal to that. No. If I'm not mistaken, they should fix it. Let's just make sure. There falls the good old cannonball. Okay, well, something worked. It fell through and it's back. Map height minus max.y. Why is it up there? Okay, let's just check if this is done correctly. So, debug, not right line. Then, let's just check. Because if min is not calculated correctly, or max will be bad. Let's see, output. Okay, it is increasing. -3. Okay, let's just stop this and go back in time. Not always ideal to do debugging like this. It works. Ideally, you want to have an entire case just for debugging. Set up, know your debugger. Don't be like me. Know your debugger. Because Visual Studio is very helpful. You can put in breakpoints and you can just inspect each variable. Okay, so we can see x is that, y is that. Okay, where do we set map height to be 400? So this is becoming -404. That's a problem. It should be 396. So let's go back to player system. No, not usual body or player system. This guy. Let's see here. Position is equal to 400 minus max.y. See, what we are doing is we're saying map height 400. Please excuse the leaf blower in the background if you're hearing it. I just can't tell him. He won't listen if I'm going to tell him to stop. So what it's doing, it is taking 400 and it's minusing the current position, 394, from it. That's not great. So what you actually want to do, you want to say minus the width divided by 2. No, height. Working with hey. What you doing? Come on. There we go. Height. It's working with y and not x. With x, it's vice versa. Let's see if it's working again. There it goes. Falling. Stop. You see? I can just, if this thing can zoom in. But look at that. It's nice. Now it's just landing nicely on the edge. Let's apply this to every other statement, these 4 statements. So we say if the maximum x, if, in other words, just go back here, if this little point is greater than this, we want to move the center back by, like, what's it, the map width minus the actual center itself. So we don't want just to move it that, we want to move it this little bit more. So that will be the width divided by 2, since that's the origin we're using. Same goes for this. We'll just say it's equal to the width divided by 2. And this will be the height divided by 2. Let's run this and let's see again. Yeah, it's falling again. There we go. Oh, it's working. Kind of. Problem is, spacebar is not working. Question is why? Why doesn't spacebar work? Let's just remove our debugger there. See here. Maybe it's just because of lag, because of the debugger. No, not working at all. 2-player system. See here, he's on ground. Okay. So we now need to change this. We want to say if RB max y dot y. Because previously we used the center. If the center is equal to the map height, then we can say it is grounded. But now, since we've put in max and min, we need to check if this max, this point, that is already here. So if the cube is here, or whatever you like to call it, the square is here, we will check if this little thing, this point, max y, is equal to map height. Just test this. Never believe yourself, test it beforehand. You might run into mistakes like I just did. And there we go. Our little cannonball can fly. Or jump, not fly. Okay. This is Flying Fox. So that is not a fox. At least it can kind of fly. Just open assets. It's not opening. Come on. There we go. Here's our fox guy. So what we will do is we'll just go here. I want to use this particular texture. So that if you look here at the bottom, this little thing, watch that. So it will be 012. that is the position of the top left corner of our texture. And the other position, maximum position, is 1125. So that means we will need to put that into, where is it? Yeah, we want that specific point. So 0, 12. Okay. So 11 minus 0 is 11, and 25 minus 12. So that's the difference. The difference between this point, the width and the height, is 13. Okay. So if we go back into play system, it's no longer 8 by 8. It is now 11 by 13. Just double check this. So otherwise you get the creeper from Minecraft. That's what Notch had. What happened to Notch? Let's see here. So it is 11 in width and 13 in height. There you go. Save this, taste it. The center will be different. It won't work correctly since I didn't change these two variables. But we first want to see if the texture is correct. There you go, texture is correct. Okay, now let's just move the center up a bit. It was, let me see, 11, 13. Going down. Huh. Something's wrong. Let's see. This is the width. This is the width. This is the height. This is still working in the center. So 11 and 13. 0 and yes, 13. Yeah, something's wrong. Might be because we're dividing 13 by 2 and that's giving 7.5, but we're using an integer, so that means it will register as 6 or 7. Let's see here. Rigid body. Like this all floats. That doesn't solve our problem. More debugging. An awful lot of debugging for a stream. Still the sentence. See, that's not right. That means this is not correct. Okay, that part is correct. Probably because I'm messed up this. The width of the thing is 11 and the height of the thing is 13. Tell me why. What is your problem? Hmm. 11, 13. Okay. Go back to rigid body. Use primitive. Okay, let's just not use primitive technology. Let me show you how you can do this properly. One of the ways. Let's say, for example, we want to check if this is correct. So we put a breakpoint here. We run it. Now the code will stop immediately. As you will see, you won't have a chance to do anything. Okay. So first we will disable this because we want to check it when it's at that point. There you go. Now put that on. Step into it. Now we can just check from your variables what's going on. So max is wrong. 400. That is kind of correct. Let's see, width is 11. Where's height? Did we even initialize height? Yes, 13. Okay. Just step to the next thing. And let's just check what this did. 393.5. Okay, that is correct. Let's see. Did I just, was my math incorrect? 1125. 5. This is 12. That is 13 pixels. See? Yes, indeed. Okay, interesting. Now, why aren't you working? This is why you duct tape it first, so you can quickly debug. But it's not quick. So, do what I say, don't do what I do. Let's see. My force isn't ground, blah blah blah. Let's see, map height. Okay. Disable this again. Go again. See what's happening. Is max dot y just incorrect, or is position dot y incorrect? So I think max dot y is incorrect. Max position dot y. Yes. What's this? No. That can just be because of integer floating point precision. When you divide a float by an int, you get a float. No, an int. It just makes 14. See? Still not working correctly. That's okay. For now, it's doing what we want it to do. That's what's important. Now we can clean up the code. This is the point where you clean up the code to check if you made a mistake. So every sprite, well, anyway, it's just, sprite is not implemented correctly here. It's pretty terrible. So we will make it better. We'll draw, and we'll take a sprite batch. Sprite batch. And we will just copy code here. This is essentially what you want. You'll not. This is a reference, probably better to name it like that. We have the texture, so we can just say texture, show this texture at this position. Ah, you see, that's where the mistake is. The origin. I set the origin to 4.4. That is incorrect. It's no longer the origin. So we'll just change the code. The public, let's get the width of the texture. Int width. Public int height. These textures all work with pixels, which is an integer. So put that in. No, actually we don't need that. We can just say width is equal to texture dot width, and height is equal to the height of the texture. Now we can say public vector to the origin. We will set origin equal to the new vector, which will be the middle of the sprite. There we go. And we will use it here. Origin. Now we can just go return to flying fox and say get the sprites, and then even we can simplify this. S dot draw using sprite sprite batch. There you go. Come on, Visual Studio, load a bit faster. There we go, and it's fixed. Duct tape against the wall, and then you hammer it. Or better, let's use a less crude example. You measure twice and you cut once. So in code, you measure it by creating something quickly, and then you cut it by implementing it correctly. Okay, let me just change this back to, I think we can just do 30, because that was correct. Okay, now the screen is very small. We want to make it larger. Again, there are a few ways to do this. Since we don't worry too much about precision, just do this. Hey, come on, Paint. There we go. And make this as large as possible. And then if you can make, oh boy. Select this and just delete it. There we go. Take this. Okay. So there's our little screen, this little square. And that's our game window. So not our game screen. This is our actual display. Excuse my handwriting. And this is our game. If you're going to support many different devices, you will find there are many resolutions. So for example, the laptop I'm using currently has a resolution of, I think it's 366 by like 820, I think. That's a disgusting resolution. But you want to support multiple resolutions so people can play your game and it will scale properly. One way of doing this is you find the difference between the size of your game and the size of your display. Basic math, you will say, for example, this divided by, let's say our game window is 320, and this divided by 180. Problem is with this approach is this will give you, let's say, for example, if we divide these two into each other, I get my calculator. Go into this, this, and this. This will be 4.27. Just round it off. Oh, that's not a 4. So that's 4.27. Problem is, it's not pixel perfect. That means if you want a precision game, it won't align perfectly. That's kind of the issue for precision platformers. I'm not going to create a precision platformer, or at least this current platformer, I don't really care about it. So I'm just going to multiply my game window by that using render target. A render target is like it's like a texture. So you draw to the texture. So let's say you draw to your render target, which then scales the thing, let's say by 4.27, and then you draw it to your screen. More accurately, actually, when you draw it, you will scale it. So now, here, this arrow, you scale. Okay, let's do this. So we will go to our game folder. Ideally, you actually want to do this in different scenes, but for now we're not going to do it. I just need to make sure I have the code here correct, because if you do this weirdly, it's gonna be weird. Just trust me, and always trust me, but now trust me. Let's go. Okay, so first off, we'll say they're in a target. Let's just see if I already did this. The target to the is equal to graphics device. Is equal to a graphics device dot adapter dot, no wait, we just do yourself a favor. Don't be like me. Go read the Monogame documentation. They explain this nicely. They don't explain why you do this, but they do explain what each function's name is. So let's say we want, you don't have the screen width here. We have the map width, so that's how large map is. This is how large our little game window is, virtual width. So let's just clarify it, because we'll add more. The width of the let's just say bounds of the map. And this is the bounds of the game window, virtual game window. And now we will create the bounds of the screen. So private constant int. Later on you won't want this to be a constant. That's it. Make this read only, because you will set this in initialize read only. Screen width and screen height. There you go. Okay. So in initialize, you will say screen width. By convention, it's not JavaScript encoder. Come on. Screen width. Traditionally, just by convention, it's always first width and then height, if you don't know. So we will say graphics dot, I think it's, let's see here, what's this play? Okay, let me just check on Monogame docs. Monogame display. Google, your best friend. No. Monogame. What's this? Graphics device. Go class graphics device. New instance here. We know that. Properties. Yeah, it's not one of these, I think. I think if you go into the adapter, the graphics adapter, is it? See? Yes, exactly. See, it's smart screen now. Let's check here. Graphics device. Yeah, it was the adapter. So graphics dot adapt. Is this the graphics device manager, or just graphics device dot? We have adapter here. Graphics. No, okay, we don't. Graphics device dot current. Adapter current display mode dot width. Okay, we'll no longer use read only. since it's gonna complain. Okay. And the height will be equal to the same gigantic statement. Height. There we go. We'll change this, put it here, because we need these two variables to be initialized. Okay, we're in a target. Look at this massive statement. I once heard that when you use free, it's already bad. But in OOP languages, you don't just use free. You use like 7. Let's see here. Yeah, look at that. Just becomes bigger and bigger. I don't like using more than 3 parameters, but whatever works. Render target. There you go. Okay, render target has been initialized. Now we want a scale. So this will be private matrix scale. But to create the scale, we will go into here. And people will initialize it. Yeah. So this will be scale equal to matrix dot create scale float. This is not my code, by the way. I got it from the Monogame forums. Some of it is mine, but not all. The specific scaling is not really mine. So check it out. I'll put a link in after the recording of the video. Let's see here. Screen height. No. We want it to be a float. Screen height. Draw height. I don't know if you're new to programming languages, you will see I use float here. This is because both of these are ints. If you divide 2 ints by each other, you will get an int, and that will round off your numbers. You don't want that. Not when you're scaling something. And we will say 1. F. Because this is X, Y, and Z. Okay. Now go down and we will say in the draw code. First, we will say sprite batch. Sprite batch. Set. Wait. Graphics. Not graphics device. Dot set render target. Set the backdash to the render target, as I explained. Now, let's just pick a background color. We will use the good old cornflower color dot cornflower blue, as always. Okay. Once you've done that, back, just make sure you do this correctly. Yes, indeed. Now, what you're going to do is you're going to draw everything, and right before you draw, you say sprite batch.end. Right after it, sorry, you are going to draw it to the screen. So this, let's just label this draw to and the target back buffer. And draw to virtual display. No, this will be the actual screen. This is the virtual display. That's back buffer. Okay. So first you will say sprite batch. You will set it to null. So when you say graphics device dot set render target, no, that should revert it back to default. So that means it will draw to the screen. Now you can just say sprite patch begin. Just use front to back. No point clamp. So it's sampler state. Point clamp. Because we're using pixel art, it shouldn't use any like filters to scale it up or down. No for default, no for default, no for default. And now, transformation matrix, this will be the scale. And we say sprite patch. Draw the render target. A rectangle. Don't like this. We'll just use new. Just use vector 2.0. Say color, no color, so that will be colored of white. And we will end the draw call. End. Let's see if it works. It won't be scaled perfectly since it initializes on the laptop screen, not on my second screen. Well, something's working because it did scale up. You won't be able to see it. It was too late. But let's go up. Let's just make sure what you're doing here. Maybe I should just quickly take away this and say window capture, and we will say we want you to capture the game. So now you will see the game. Now let's retry this. Blah blah blah. There you go. It falls. Don't know if you could have seen it at precisely the moment, but it's fine. Since we are, just put this off. There we go. Since we are using the actual screen width, we want this game to be in full screen. So graphics.is full screen equals true. How easy was that? The only easy code I've written today, I think, is full screen, make it true. Okay. And it didn't work. Now, isn't that nice if it doesn't work at all? See here. Check if I did it correctly. Always check. See. Seems like it. Maybe this just should be earlier. See, if it doesn't work, we will resume in the next episode. Because our time has run out. It does work. Great. It's ugly, but it does work. Kind of. Not really. Not really at all. It's just taking up the screen. You can't see it currently. Oh wait, did I set it to window? I'm sorry. So that concludes today's stream. I wish you